When we communicate science, one of the key parts of being objective is to be upfront about your level of uncertainty with the results. And so it's important to not hide or obfuscate the true nature of whatever values you're reporting to support an idea. So I'm going to start with what is a measurement. So all measurements are going to be two things. They're going to be a number and a unit. So let's just do a quick example. Let's say my number is 35. That could be a lot of things. That could be my age. That could be my weight in kilograms. It could be how many feet across this room is. It could be a lot of things. And so a number is just a number until we attach to it a unit that describes what the number means. It's giving it the context that we need to understand it and kind of use it appropriately. So let's call it grams. So now this is a measurement of mass. 35 grams is a measurement of the weight of something. And so the two together are essential. So whenever we are performing an experiment and recording values, and let's say we're weighing something or we're measuring the volume or we're taking the temperature, we'll always put down both the number that we're reading and also the unit. So that way we can keep crystal clear track of what we're actually talking about. Now, a lot of us, if you were raised in the United States, are used to the English system of units, while everywhere else is used to the metric system. So in chemistry, we're going to use the international system of units as kind of our base, although there are I have a few exceptions, but it's really basically the metric system. And so here are some of the physical properties that we can measure and the units that will be assumed to be kind of standard. And there's symbols that go along with them. So length will always be in meters. The symbol is a lowercase m. Mass, the standard unit is kilograms, although I'll say that typically we actually use, so in the metric system, the base unit here would be grams. Which makes kind of prefixes that we'll talk about here in a second make a little bit more sense. So time is going to have a base unit of seconds. Temperature will be Kelvin. I don't know if you've ever heard of this one. We'll talk about it in its own separate video, but we'll work in Kelvin. Amounts of things will be in moles. Electric current, which won't really be a part of this class, would be an ampere. Luminous intensity, again, not really part of this class at all, would be a candela. I can never say it. Moving on. So again, mass, we're typically going to work in grams right here rather than kilograms in the chemistry lab. And also one of the things that's missing from this list of international system of units is volume. So volume is something that we measure a lot in chemistry because we work with a lot of liquids. And so it's easier to measure out a volume with markings rather than take its mass typically. And so kind of the base unit for this in the metric system is liters. And the reason I think I'm focusing on the base unit is because we can modify and we can communicate the size of something by using prefixes with the metric system or these standard units. And so these are the prefixes that are most common, at least in chemistry, and their meaning. And so if I had grams, right? So I had that 35 grams. I could have a unit of a numeric value that is measuring something that's very, very small compared to that. Maybe it would be 35 milligrams. Or this would be abbreviated mg. So a milligram right here is going to be 1,000th of a gram. So 35 milligrams would really be only 0.035 grams. would be equal to each other because each one of those milligrams is just 1,000th of a gram. Things could also be really big too. So when we talk about kilograms, those are going to be 1,000 times bigger than a gram. So 1 kilogram would be equal to 1,000 grams. And so these prefixes are a way of allowing us to report kind of like easier to digest number, and make the unit kind of fit the magnitude of it instead. So we can talk about really tiny things in nanograms or nanometers, and we can talk about really big things in megameters or megagrams. And so this will be a prefix that changes the unit right here. And so you'll be exposed to different ones of these, and this kind of just gives us a reference point to some sort of base unit. So like your gram is your base unit, and you might see things that are milligrams or nanograms, or you might see kilograms. And if you see kilograms, you're like, bigger than a gram. You see milligram, it's smaller than a gram.